Hello class and welcome to lesson 4.2 working with integer exponents. This is the first, although it says 4.2, it's still our first lesson in the unit. I'm just trying to match the textbook. We just don't deal with section 4.1 in your text, okay? So if you're wondering about how I number them, that's what I try to do is follow the textbook order there. All right, let's start up with some warm-up, see what we can remember from grade 9 and 10. Exponential form, another word for that is power form. And that's where you have the base raised to the exponent. Expanded form is where you take the base and expand it out the number of times the exponent tells us. And numerical form is the answer itself. All right, so let's take a look for our warm-up. 4 to the power of 5 in expanded form, that's going to be 4 times 4 times 4 times 4 times 4. So you repeat 4 5 times and plug that in your calculator 4. And you're going to either look for the hat button, the y to the x button, or the x to the y button. In most cases, check your calculator out. You should know by now which exponent button you use. And you should get 1024. Looking at our second example here, we notice that our base, which is repeated 4 times, is -2. The -2 has to be part of a bracket inside the bracket before you raise it to the exponent 4, which is the number of times it is repeated. And using your calculator, ladies and gentlemen, you should get the answer of 16. Now, when you're given it numerical form and you're asked to solve either exponential or expanded form, in many cases you could have more than one answer. For example, if I used the base of 5, I would have 5 times 5 times 5 times 5. I could also have -5 times -5 times -5 times -5. Or I could use a base of 25. So I'll just change colors here. I could have 25 times 25. Or I could have -25 times -25. So based on which example you chose, you should then say, hey, if I'm using this example to begin with, then that my base is 5 and I'm raising it to the exponent 4. Or the one below that is -5 raised to the exponent 4. If you used a base of 25, it's going to be 25 to the exponent of 2, or -25 raised to the exponent 2. Let's take a look at the second question, which means to solve. Again, you're going to have to apply some of your integer laws or just simply plug it into the calculator. So when we take a look at A, ladies and gentlemen, we have to realize that the negative sign is part of the base. And when you have an odd power, or an odd exponent that has a negative base, you know that's going to result in a negative answer. Just think about it. Negative times a negative is a positive, but then you got to times it by another negative, gives you a negative result. And 3 times 3 times 3 is 27. If you're plugging in your calculator, ladies and gentlemen, make sure you put opening bracket, -3, closing bracket, then exponent button 3. Okay? That's different than the second example, ladies and gentlemen, where you look at -3 cubed. The 3 is the base, so the negative stays out front, and then you're going to deal with 3 cubed. So it's really going to be -27. Okay, again, it makes a difference if the negative sign is out front or part of the base. All right, second example, ladies and gentlemen, if you have a fraction base, the exponent of 4 applies to both the numerator and to the denominator. So just to make sure you know that's 1 to the 4th divided by 2 to the 4th. And then you could solve both the numerator and the denominator. So 1 to the power of anything is 1, and 2 to the power of 4 is 16. So the answer is 1/16. All right, taking a look at example D, this is remembering our zero exponent law. And anything raised to the exponent 0 is 1. Just be careful here, folks. If I had -22 and I put it in brackets and put it to the exponent 0, that again equals 1. But the problem here, guys, where I lose people, is that -22 to the exponent 0, the negative part is out front. It's not part of the base. So when I go to solve my exponent part first, it's going to be a negative sign out front times 1, which is going to give you -1. So when you have the zero exponent rule, ladies and gentlemen, remember anything raised to the exponent 0 is 1. But if you have a negative out front, like in the screen section, it's not part of the base. All right. Let's take a look and do a quick review of our exponent laws to help us. Again, you can write down what information you need to know. Many of these you've taken a look at since grade 9, and you might just need to write down the simple rule. All right, so the first law we're going to take a look at, or the first rule, is the multiplication rule. Okay, when you have when you're multiplying powers with the same base, you keep the same base and you add the exponents. Okay, so what's this going to look like? It's going to be b to the m plus n. That's multiplying. When you have a power rule, ladies and gentlemen, it's an exponent raised to another exponent. To determine the power of the power, keep the same base. And in this case, you're going to multiply the exponents. So it's going to be b to the m times n. All right. Division rule. To divide powers of the same base, keep the same base and subtract the exponents. So it's going to be b to the m minus n. Okay, to help us develop a pattern for our negative exponent laws, let's just quickly do a recap of some patterning here. Okay, 2 to the power of 3 is 8, 2 to the power of 2 is 4, 2 to the power of 1 is 2. Again, we've learned that 2 to the power of anything is 1. Let's just, before we finish the rest, let's see what the patterning, what's happening each time. So to get to 8, to get to 4, to get to 2, to get to 1, what's happening? Hopefully you realize that every time it's getting divided by 2, or you're halving it. Okay, so for example, 2 to the -1 is 1 over 2. 2 to the -2 is 1 over 4, which equals 1 over 2 to the power of 2. And this is 1 over 8, which is 1 over 2 to the power of 3. All right. So what we should remember, ladies and gentlemen, with the negative exponent law is that when it's negative, you flip it or form the reciprocal of it to make it positive. It is bad form to leave an answer with a negative exponent. All right. So let's take a look at when you have a solid number. So for example, if I had 5 to the -2, that's going to equal 1 over 5 to the power of 2. What happens if we had a fraction base, ladies and gentlemen? What if I had 2/3 all raised to the -3? Well, basically, you flip it or find the reciprocal. So 2/3 become 3 over 2. And now the expression or the equation becomes positive with the exponent. All right. And to develop the pattern for the zero exponent law, y does it equal 1? If we take a look at 2 to the power of 6, well, plug it in your calculator, ladies and gentlemen, you're going to get 64. So 64 divided by 64 equals 1. Okay? Using the quotient rule, ladies and gentlemen, we know that we subtract the exponents when we're dividing. That gives us 2 to the exponent 0. And because these expressions started the same, that means we must know that 2 to the 0 equals 1. So there's a quick proof on the zero exponent law. Okay. Taking a look at the exponent rule, I just reviewed it in the warm-up. Anything raised to the exponent 0 is 1. Be careful if it's negative sign out front or part of the base. So negative sign out front will produce a result of -1. Okay, we'll give you a quick example like we did on the first page. So negative 22 exponent 0 equals, it's negative out front, 22 to the exponent 0, that equals 1. So it's negative out front times 1, which gives you negative 1. All right, now that we have explored these exponent laws, let's practice doing some integer work without using the calculator. Okay, i.e. you're going to use these exponent laws that we've just learned. Okay, so evaluate without a calculator. First of all, for a, I recognize that the exponent is negative, so to make it positive, it's going to be 1 over 5 to the power of 3. And 1 over 5 to the power of 3 is 125. Okay, second example, ladies and gentlemen, my base is negative 4, but I have an exponent that's also negative. So let's take care of the negative exponent first. It's going to be 1 over negative 4 to the power of 2. So it's going to be 1 over negative 4 times negative 4 gives you positive 16. So your answer is 1 over 16. Taking a look at C part, ladies and gentlemen, be careful. It's different than B because the negative is not part of the base. So leave the negative out front and then take a look at what we're going to do with the negative exponent. It's going to be 1 over 4 to the power of 2, which equals 1 over 16. But don't forget to times it by the negative out front. So the final answer is negative 1 over 16. All right, moving on. D. We have a negative exponent law, so we're going to make it positive. Okay. And that's going to be 1 over, well, 3 squared is 9, and square it again is 81. All right, E, anything raised to the exponent 0 is 1. F, anything raised to the exponent 0 is 1, however, the negative one's out front. So just treat it a little differently. So your answer is negative 1. Okay, looking at G. Again, we have a fraction base and a negative exponent, so you flip the fraction and make the exponent positive. So that's going to equal 4 over 1, which just equals 4. Okay, let's try that again, but a little more difficulty here. Okay, so flip the fraction, so it's going to become 5 over 2, all raised to the exponent of 2. Now we're going to realize that, hey, the exponent applies to both the numerator and the denominator. So it's going to be 25 divided by 4. Okay, again, we're going to flip the fraction, so it's going to be negative 3 over 1. Make it positive, the exponent. I apologize, I have to sneeze. Okay, sorry. Excuse me. Sorry about that. So what we need to do is realize that negative to the power of 3, it's odd, so it's still going to be negative. And 3 cubed is 27 divided by 1, so it's just negative 27. Okay, looking at J. For J, we're going to use our exponent laws. So first of all, we're going to take a look at what's going to be left on the numerator. It's a multiplication, and multiplication tells us we need to add them. So 5 plus a negative 2 changes it to minus 2, divided by 3, and it's power of a power, so you're going to times those. So we're going to end up with 3 to the power of 3 divided by 3 to the power of negative 6. We're now going to use our our quotient law, which means we're going to subtract those. So it's going to be 3 to the power of 3. Subtract, but when you subtract a negative, it becomes a positive. So it's going to be 3 to the 3 plus 6, which equals 3 to the power 9. Plug that in your calculator, ladies and gentlemen, and you will get 19,863. That's one, ladies and gentlemen, that I wouldn't expect you to do without a calculator, but I wanted you to do all the steps first. So you should have been able to get to the single exponent of 3 to the 9th before plugging that in your calculator. All right. And taking a look at the last example here, we have 4 to the power of 6 plus 2, which is 8, divided by 4 to the 2 times 4, which is 8. So that just answer equals 1. All right, so there's a good practice of our exponent laws from grade 9 and 10, and we need to make sure we've got a solid base of these exponent laws before we deal with taking that exponential function any further. So here's your homework today, folks. Page 221, numbers 1, 4 to 6, 8 to 10, try 16, it's a hard one, and 18. Have a great day, and again, come see me if you need any help. Goodbye.